The height of the water h in feet at a boat dock t hours after 6 a.m. is given by h equals 10 plus 4 times the sine of pi 6t. I actually prefer to think about this as 4 times the sine of pi over 6t plus 10. I always like to rearrange my trig functions to look like that. It just makes it easier for me to think about it. And in part A, we're given several times of day, 6 a.m., 9 a.m., 12 p.m., 6 p.m., midnight, and finally 3 a.m., which we're then going to turn into some t's, which are in hours, and then use the function to turn those into heights above the water in feet. So the variable t is the number of hours since 6 a.m. So 6 a.m. itself would be the 0 hour, 3 hours later, 3 hours after that, and then we have a little jump here when we go 6 hours later. So we're just adding in the number of hours later to get to 12 a.m. midnight. We're another 6 hours out at 18, and then finally 3 more hours after that, 21. And now we just need to evaluate our function at these. Well, if I plug 0 in, I get the sine of 0, which is 0, times 4 plus 10, 10 feet, which is just right in the middle of this wave function, right? Sine goes up and then back down. And so now I need to plug a 3 in, and well, when I do that, I'd have 4 times the sine of 3 pi over 6, which is pi halves. Well, I know the sine of pi halves is 1, times 4 plus 10 is 14 feet. All right, we just keep going in this fashion. Now I plug a 6 in, right? 4 times the sine of pi 6 times 6 is just pi. Sine of pi is 0, so I'm back at 10 feet. 12 hours later, that would be 4 times the sine of 2 pi plus 10, again, 10 feet. And I think we can figure out what happened in between at 3 p.m., right? And that if we kept growing by 3, plug in an 18. And that would be a 3 pi. All right, so again, we get that 10 out, and then finally 4 sine of, and briefly I'd have a 21 pi over 6, but then I realize that that one I can reduce and divide top and bottom by 3, and I would have 7 pi over 2. All right, well 7 pi over 2 is coterminal right there at 3 pi halves, where sine's equal to minus 1. I'm going to get a 6 out. If I think about it, this is a sine function that's waving around a center line at 10 and going up 4 units and down 4 units. So 14 and 6 are the highest and lowest things I could ever get out anyway. And that really brings us to question B. When is high tide and when is low tide? All right, low tide has to be at 3 a.m. High tide has to be at 9 a.m. Just looking for the largest thing and the smallest thing. And even if I hadn't built this table, I think I could have imagined what I was looking for just thinking about what sine does over one full revolution, over one full period. Speaking of periods, in part C, we're asked to address what the period of this function is. All right, well, the period of a sine function is 2 pi divided by b, the number in here in front of the variable. All right, so I get to simplify that, and I find out the period is 12 hours, which means we repeat this shape, this one full shape, every 12 hours. And that's it for now.